Right, let's recap domain and range. So we know that the domain is the set of x values in a function when the function or relation exists, graph, and range is your y values. All right, so before we get started with that, we're going to look at this function, these three. So we've got a square root, circle, and a rational. Just want to remind you about some of the things you have to keep in mind, especially over here. So when we've got a square root of something, we know that we cannot take the square root of a negative value. We know that we can't divide by 0. So these are some of the things that are going to affect our domain. Over here we see, better change the color so we can see. Okay, so over here we've got when it's like a value, if we wanted to say x here is between a and b. Okay, we write it like so. It's less than or equal, x is greater than or equal to a because it's got this closed bracket. If it was a round bracket, as we see down here, then it's just going to be greater than. So keep that in mind, but as we go through, we will be using that notation. This is the same, but I probably won't do that. We'll just do the 1. All right, let's have a look. You can use, we'll use our graphics calculator to help us do this. So the first one we can see here. Okay, we're going to look at the x component first. That's a little bit hard to see, isn't it? We'll go back to this. So our x component, and we can see clearly that our x value is going to be between -1 and 2. So to write that, use your curly brackets. Okay, and we're between -1. I'll pop the 2 here. Now it's a closed dot at the 2, so it's less than or equal to 2, but it's a round dot at -1, so it's greater than or equal to -1. When we do the range, we can't just take these y values here. We have to consider any minimum point as well. So we can see that that point there is 0, 0. Okay, so your minimum of y. So we can now say that your y values, your range, that's going to be, y has a maximum up at 4, but then it's got the minimum of 0. Now, can it actually be 0? Yes, it can. It's passing through that point. So y is greater than or equal to 0, but less than or equal to 4. Okay, when it comes time for a square root function, we can do a couple of things. We could use our graphics calculator, but before we get to that, I am just going to write here that we know the thing that's underneath the square root, we know that that has to be greater than or equal to 0. Okay, so get rid of the +12, pop it on the other side, it becomes -12. Now to get rid of that times -6, we divide by -6, and we do remember when we're dealing with inequalities, if you multiply or divide by a negative, right? So I'm going to go this -12 over -6. Because I've divided by -6, I have to change the sign of the inequality. So do make sure that we say it's less than or equal to +2. So that's my domain, x. X is less than or equal to 2. Let's have a look at what that looks like on our graphics calculator. Alrighty, so into our graphing mode, let's just pop that in, 12 take 6, x. Enter before we graph. Let's have a look, shift view window, probably press standard, let's go with that one. Okay, so we can see there that we agree x has to be less than or equal to our 2 value there, gsolve root. We could use your trace function. Okay, and then looking at your y values, clearly, clearly they just keep on going and going above the x-axis. Okay, so hopefully you agree that we can see there that y has to be greater than or equal to 0. Have another look at that. Do we agree? All above? Okay. Let's have a look at the next. Okay, now this is an equation of a circle. It could be given to you in a nice form as a diagram even. We're just going to go through and remind you, how do we get it into our nice form so we can get our center of the circle. So we look at the x squared and the minus 10x, and we want to complete the square here. So divide minus 10 by 2. That gives us the 5 squared plus, then we look at the y components. Okay, so we've got y squared and we've got 8y. So again, we divide that 8 by 2. So we've got y plus 4 squared. This 3 goes over the other side. Now, we can't just leave it like that, because when I expand x take 5 squared, I remind you that that's going to give us, it's x take 5 times x take 5, and that gives us, sorry, I just have to write that. That will give me x squared, take 5x, take another 5x, so take 10x, which is exactly what we wanted here. But we're also going to get this plus 25. So because we've added the 25 in there, we need to also add it to the other side. Similarly, when we expand y plus 4 all squared, we'll get the y squared, we'll get the 8y, but then we'll also get a 16. Okay, so this gives us a circle with center 5. So we've got center 5 minus 4, and we've got a radius here of 44. So how does that help us find our domain and range? Well, let's picture it. So again, whenever you're stuck, oops, that's not a very good one. Whenever you're stuck, try to draw a diagram. It always seems to help. All right, so here we go. We've got that circle, and we've got the center is 5 minus 4. Now, if we're looking at our domain, it's going to go out that way by root 44. What happened to my square root on the 44? That disappeared. Okay, and of course it's also going to go root 44 right the other way. So let's pop our domain here, and I would say that x will be in between 5 plus root 44, and of course 5 minus, oh, the pen's giving a little bit of trouble today, 5 minus root 44. Hopefully that makes sense. And naturally, with your range, it's going to be the same thing, but instead of now the 5, it'll be the minus 4. Okay, oops. My pen is having a little bit of a problem today. So we've got minus 4 plus root 44. And I'm just realizing now that really we should simplify that. So take root 44. Sorry if things keep disappearing here. So I'll put a little note that you should actually simplify that. Always check and simplify. I was naughty and didn't do that. That's going to be 2 root 11. Okay, so hopefully that makes sense. Just, you know, you might be given that as a diagram, but you can see the range is obviously contained, right, between those points. Right, onward. All right, now we've got a rational function here. And we should know a couple of things about this already. Right, for starters, when we look at the denominator, okay, we know that x cannot be minus 2, because if it was minus 2, then we're dividing by 0, and that doesn't happen. So we should know that we actually have a vertical asymptote at x equals minus 2. We also have a horizontal asymptote here at y equals minus 3. So as long as we know that, we get the fact that we've got our domain. We can just write it as x does not equal minus 2. And our y values would be the range y cannot equal minus 3. Just realize that some of the examples there, I mean, I hope you guys realize that if we had a function like y equals 3x plus 2, and we didn't have any limitations on that, okay, so it's positive slope, it's going onward and onward, then how do we say that x could be any number? That's just coming down to your notation. So that's how we get and how we write x could be any real number, and we do the same for your y value. All right, let's have a quick little recap and see, does this make sense with our graph? So we pop that in, 6 over x plus 2. Let's pop it to standard notation and standard, and yep, that looks pretty good. So the only values right here along that point there, that's y equals minus 3 and x equals minus 2 would be my vertical asymptote. So basically just have a look at the graphs,